In this experiment, you will be using the HPLC to separate out the components in common soft drink samples. For the day 1 of the lab, you'll be determining the optimal mobile phase composition for the separation of these components, and then in day 2, you will construct a caffeine calibration curve to determine the concentration of caffeine in various soft drink samples. So you'll be preparing all of your solutions on day 1 of the experiment. There's a couple things to note. The first thing is for all the solutions that are prepared in this lab, you need to use the HPLC grade water. And this water is found in the bottle, which is labeled HPLC grade water. So again, do not use the millipore water from the carboy or from the sink. You must use the HPLC grade water in the container. The second thing to note is some of the components, especially benzoic acid and aspartame, are going to be very difficult to dissolve. So you're going to need to both sonicate and heat up these samples. It is okay in this experiment to put the volumetric flask directly onto the hot plate. Just make sure you do not have the temperature of the hot plate greater than 80 degrees Celsius. Once the solutions are all dissolved, you have to make sure that they come to room temperature before you dilute the solutions to the mark on the volumetric flask, and then subsequently filter the solutions. For the soft drink samples, you're going to need to sonicate them before you filter them into the vials to get rid of the carbon dioxide. Any air or carbon dioxide bubbles are very bad for the HPLC column. So to sonicate the soft drink samples, you just will take a little beaker and pour some of the beverage into the beaker, and then you will just place it into the sonicator, and then you can just turn the dial. There's this dial here which has numbers which show you how long you will sonicate the beverage samples for. So when you are putting the beverage samples into the sonicator, you want to make sure that the level of water in the sonicator is about equal to the amount of beverage that you have in the beaker. You want to sonicate the beverage samples for at least 20 minutes just to make sure all the carbon dioxide bubbles get out of the solution. So you need to filter all of your solutions before you load the vials into the HPLC. So to do this, you make sure all of your solutions are poured into a beaker, and then you need to open up the syringe. And all the syringes are sterile, so you do not need to clean or rinse them off before you use them. If there's needles, just very carefully remove the needles. And then you need to, I like to open up my filter before I suck up the solution. It just makes things a little bit easier. So you need to suck up the solution again before you put the filter onto the syringe. So to do this, you just place the syringe into the solution and just gently pull up. And then you just tightly screw down onto the filter. And you want to make sure this is a tight seal, otherwise when you push the solution through the syringe, it'll come out of the place where the filter meets the syringe, and it will not go into the vial. It will go over the bench top. And then you can just hold your vial, and I like to just kind of set the filter straight onto the vial and then just gently push the solution through. You will notice when you first do this that the solution will not go straight into the vial, and that is because the solution is actually wetting the filter. That is okay. You can just keep pushing the solution through until you get it into your vial. All right. And then you can just take your cap and cap it on. Now this is ready to be loaded into the HPLC. You want to make sure that the solution volume is about at this top line here on the vial. That is a good amount for the HPLC. And just a note that you make sure to use a new syringe and new filter for each of the different solutions that you prepare. You can log into the computer with your own Hakadine password, and then you are going to want to click on the chromeleon icon. And you can just close out when the tip of the day pops up and maximize the window. All right, so there's a couple of things that we should do before we create our sequence. So you want to click on the 5th icon from the left. It's default panel tab set, so you want to click on this. And then you're going to double click on My Computer, click on the chromeleon server, and then hit OK. And this brings up a window which we can now access the diode array detector, the sampler, and the pump. So the first thing we're going to do is we're going to turn on the UV vis diode array detector. You need to let the diode array detector warm up about 10 to 15 minutes before you inject your samples. So you're going to click on the DAD tab. And then what you are going to do is there's 2 buttons here on the left-hand side of the screen, the UV lamp and the vis lamp. So you want to click on both of them. And as you can see here, it says UV lamp igniting and vis lamp igniting. And once the lamps are on, they will turn this kind of dark gray color. The next thing you're going to want to do is we are only going to use the UV vis 1 lamp, so you're going to want to double click on the UV vis 4, which is in green. And this brings up this window, and so we are just going to remove all of the UV lamps except for one. So in this displayed signals, you can click on UV vis 2, and then you can click on remove, so that just removes it. And do the same thing for 3 and 4. And then you can just hit OK. So what you can notice now is now we just have the UV vis 1 lamp. All right, so the next thing we want to do is we want to bring the tray to the front where we set our sample vials. So click on the sampler tab and notice this tray control sort of column here. And we loaded our samples into the red tray, so I'm going to hit tray to front. And that brings the red tray to the front. So if you needed to load more samples, or if you want to double check the positions of your sample vials, you can always go to the sampler tab and hit tray to the front. The last thing we want to do is we want to flush out the column. So you want to flush the column about 10 to 15 minutes before you do any injections. So to do that, you're going to click on the 3rd tab here, and it starts off with Exp8. And you want to, we are going to flush the column with an 80%, 80 to 20, 80% water to 20% acetonitrile mobile phase. And you want to set the flow rate at 1 ml per minute. You can type it in like this and hit enter. And as you can see, the flow rate is now increasing up to a minute. You could also drag this green arrow up to 1, or you could also click here up to 1. So there's a couple ways to do that. All right, so now we want to let this, we want to equilibrate the column for 10 to 15 minutes before we inject our samples. Once you turn on the UV vis lamp and you get the column equilibrating, you can start to create your sequence 1. So to do this, you want to click on the 143 analytical measurements to save as folder. And so it's the top one here, right under the to data folder. So click on this. And this brings up now this window where now we can add samples to our sequence. So the first thing you want to do is you want to save the sequence that you are going to be creating. So File, Save As, and it's going to save under the To Data folder. I'm going to name this as 143 video 2014 test. Okay, great. And now you can see my saved sequence folder popped up here. So now when I modify my sequence, it's all going to be saved into the folder I just created. So to add samples to our sequence, you click on the sample name, and then you right-click and you can go append sample. And so append sample means you just are going to keep adding more and more samples. Now you want to change the name of the sample. So for our sequence 1, we have solutions 1, 2, 3, and 4. So the first sample I'm going to inject will be sample 1. Second will be sample 2, and so on and so forth. You can also do the same for the position. So I put these in the red tray. So the code here is the letter corresponds to the color of the tray. So my samples are in the red tray, so I'm going to go R. The second letter corresponds to the row. So we are in the first row, which is row A. And then the last number corresponds to the position in the row. So my solution 1, I put in RA1. So you can do that for your other samples. All right. Now there are a couple things to note again. You want to make sure that all of the statuses of your samples say single. This means that they have not been injected into the column yet. And also that the injection volume for all of your samples is 5 microliters. This should be the default injection volume, but it's always good just to double check to make sure that is indeed the injection volume. If you want to check to see how the length of your runs for your samples, you can double click on, these are the different mobile phase programs. As you can see, they have the abbreviation at the end, PGM. So you can double click on this. And then you can scroll down here all the way to the bottom where it says pump pressure. And so this is the place where if you would like to change the runtime of the mobile phase program, you can do so. And you can just say if I wanted to change it to 4 minutes, I just would delete the 1 in 4 minutes. And so if you make a change to the runtime, you want to make sure to save that change. So you can keep appending your sequence list until you get a full sequence. So I'm just going to pull up my sequence 1 here that has already run. All right, so as you can see, this is my completed sequence. I just wanted to point out that you do never want to inject the same sample in a row. So if you notice, like, I have 1, 2, 3, 4, 1. We don't want to go sample 1, sample 1. You always want to randomize your injections. And also another thing to note is the program column here indicates what mobile phase program you will be using for that particular sample. So in the sequence 1, we are going to test out the 20%, 30%, and 40% acetonitrile programs. So you want to make sure that for the first 5 samples that you have the acetonitrile 20% program selected. When you are switching between the 20% and the 30%, you want to kind of inject a sort of a dummy sample so the column can flush and equilibrate again. So you will always want to do this whenever you are switching between the mobile phase program types. So here you can see here's kind of my sort of equilibration sample. And then again, I start the sample sequence over again. When you have double checked to make sure all of the sample information is correct, you are ready to now inject your sequence. So I'm going to go back to my test sequence here. I'm just going to save the name. All right. And I'm going to go to File, Save. So I'd recommend just saving your sequence list right before you're ready to inject to make sure all of your changes are saved correctly. So to inject your samples, you're going to go to Batch. You're going to hit Start. And you want to, the name here you want to load is the sequence name that you gave it. All right. So before we inject, we always do a ready check, and this ensures that we have enough mobile phase to run our samples. To do so, you're going to hit this ready check button. As you can see, it sort of gives you an approximation to how much mobile phase will be used to run the sample. So in this one sample, it's going to use approximately 11 milliliters of A, which is water, and it's going to use around 3 milliliters of B, which is the acetonitrile. It also gives about an error here at the end, so you always want to err on the side of having way more mobile phase than is actually going to be used. Okay, so that looks good. All right, when I'm ready to inject my sample, then I can just hit Start. So when the instrument is making the injection, the sample will just turn green, and that way you know that it is correctly making an injection. I just showed you what the sequence 1 looks like. Sequence 2, you will construct on the day 2 of the experiment, and this is after you select the optimized mobile phase composition for the separation. Make sure before you create your sequence list for the sequence 2 that you check with your TA about the optimized mobile phase composition before you inject these samples. Again, for sequence 2, the only thing that is different is you might want to change the mobile phase program to be a shorter runtime, and you can change that the runtime of the mobile phase program to be 1 minute longer than when the caffeine elutes off of the column. This will conserve the mobile phase and make the samples run at a more efficient rate. Sequence 3, again, is the same thing. The only thing to note about sequence 3 is you want to inject your beverage samples 3 times each. So for instance, if I have Coke injected 3 times here. And you want to inject the spike samples only once. So as you can see, I only have Coke injected, the Coke spike sample injected 1 time. Again, you never want to inject the same sample 2 times in a row. So here I have Coke and Diet Coke, which are 2 different samples. This also applies to the spike samples. So for instance, you don't want to do like Coke spike here. One thing to note is once the samples are finished, have been injected and are finished running, the status will go from single to finish. For your last sequence that you are going to inject for the day, you want to make sure to load a shutdown program. So this ensures that the column doesn't run dry and that we do not damage the HPLC column. So to load the shutdown program, you're going to again click on the batch and hit Start. And then you want to add a shutdown program, so you can go Add. And then right now we are in Sequence Object, but you want to change to Program Object. And then you're going to look in Ultimate 3000 and then Shutdown Programs, and then you can load the shutdown. And then hit Open. And now you can see that it's going to inject our sequence here, and then it's going to go to the shutdown program. And so the order in which these sequences are listed here is the order in which they will be injected. So you always want to make sure the shutdown program is the last in the list. Okay? And always make sure to do a ready check. Okay? And then you can just hit Start when you are ready to inject the sequence. So your sequences are going to take longer to run than the lab period allows, so you're going to need to come in on another day to retrieve your data. So to retrieve your data, you want to export your data in both a PDF form and a CSV form. So first I'm going to show you how to export the data in the PDF form. So you want to highlight your entire sequence list, then right click, and then you want to go to this batch report, and you want PDF creator right here. And when it says export options, you want to hit export. Okay. And I was doing the PDF file format first, so I want to hit export format and check the PDF format. Okay. So now you can hit next. And you want to make sure that you have the integration, calibration, batch, and peak analysis categories checked. And you want to make sure that you have the export for every sample bubble darkened. And you can hit finish and OK. So now it is creating my batch report. So you can give it a title. So I'm going to call this OK. And then it's going to ask me you want to hit save here. And then you can save it into whatever folder you would like. Whoops. First, I'd recommend saving it into the C drive so it's actually on the computer, so every member of the lab group can have access to the folder. So you can save it into users, and then scroll down all the way to public documents, and I'm going to create a new folder. Okay. All right, and save. Okay. So you can maximize, and this is what the PDF of all the data will look like. And now I'm going to show you how to export your data into an Excel format, which is really convenient when you start to analyze your data. Okay, so again, just to make sure all of your samples are highlighted, right-click Batch Report. Now this time, you want to uncheck Printout. You want to recheck Export. And then we want this in an Excel format, so check the XLS export format box. And then you need to actually define the location that these files will save at. Again, you want to save these on the C drive so everybody has access to it. So I'm going to go under Public Documents and Summer 2014 folder. All right. You can also choose the directory formula and the file name formula. So I'm going to pick sample as a category and have the sample name as a variable, and this will give me the Excel spreadsheets with the sample name. I'm going to just check here for the same thing for the file name formula. Okay. All right, now I can hit next, and you want to just export all of the information so you can have all of it, and hit finish and hit OK. Now if you want to double check to make sure that it's saved, so you're going to need to open up the folder, so you can click on the Windows icon, Documents. I saved it under the C drive, and Users, Public Documents, Summer of 2014. And as you can see, it's saved. Each sample had its own file name. So for instance, this Coke sample we injected 3 times, one 3 times. So each of the 3 injections has their own Excel spreadsheet. When the error popped up, you can just hit OK. And as you can see, here's your data. You have the integration and information with the area integrated. You also get the peak WIS here in the peak analysis tab. Cleanup for this lab is relatively simple. So if you have any remaining solutions in the volumetric flask, you can just dispose of these in the HPLC waste container. Also, you need to make sure you can just put the small vials that you loaded into the HPLC, you can place these directly into the red waste bin.